Hi, welcome to Talking Tech. I'm your host, Marcus Yam, and I'm back at Intel because there's something really cool I'm here to take a look at. And that's this laptop. To tell me more about that is Brett Branch. Brett, thanks for joining me. Tell me who you are and what you do at Intel.
Yeah, thanks. I am the graphics technical marketing manager for our mobile products. So I've been managing getting this laptop in this is our reference platform for our A370M product.
Very cool. And okay, so I'm excited about this because the stickers. Okay, first of all, like who's excited about a laptop for the stickers, but it's what the stickers say.
Yeah.
So right there, Intel Evo Core i7.
Yep.
And right next to it is an Intel Arc Graphics sticker. So
yep. So this platform, this is the first generation of Intel Evo platforms, which you guys know about all the great Evo goodness with being able to have fast boot times and long battery life and all that kind of Evo goodness. This is the first one where that's actually on an H series laptop.
12th gen H series.
Yep.
So that's the 6 P cores, 8 E cores. It's my little custom made shirt here.
Yeah.
With
nice.
the older H die.
A nice H die, Intel outside. This is Intel inside in the laptop.
Very nice. Very nice.
It's wearing it internally.
Yes. Cool.
But yes, that's the die that's in here alongside our A370M graphics, discrete graphics part. So that's got 128 EU execution units. There to supplement the integrated graphics.
And the integrated graphics has 96 U's.
Yep.
Okay.
So we're going to show you some really cool workloads where we can make both those engines work together at the same time to really accelerate, especially content creation workloads. So yeah, we're really excited about that.
So this is, you mentioned a reference design, kind of an example of what this combination of Intel processor and Intel graphics together. Who is the intended user for a laptop such as this? So
this, we're bringing out a whole family of laptops with the discrete graphics, right? So we have our A770, A750, all the way down to A350, which is even thinner and lighter than this one. This being, the 370, it's really geared more for the content creation. So less execution units that'll be important for gaming, but all of the media engines, several execution units, and XMX capabilities to do accelerated AI work. So a lot of the content creation applications, this is mostly for somebody who is doing content creation and wants to be able to take that capability on the road with them.
And would it be fair to say, going back to what you said earlier about this being an Intel Evo laptop, for 11th gen, Evo was all thin and light. And this is bringing Intel Evo to another level of performance that's even higher.
Yep. There are options for art graphics. Not every Evo laptop at 12th gen will include art graphics, but there are provisions for art graphics as part of the Evo brand, and this is really one of the very first ones to be able to do that.
Okay, and you said this is the A370 SKU. So what does that mean? How does that relate to the others in the kind of the 3 level with the 370, 350, and so on? So
the A770 will be our top of the line discrete graphics part. That'll have 512 execution units. We have another generation that'll have 384 and then one at 256. There's this one at so this is the A370M at 128 EUs, and then there's a laptop that's actually hit market already, the Samsung Galaxy Book 2 Pro, that's actually hit market in Korea. It's got the A350M, which is 96 EUs, so you got 96 EUs integrated graphics and 96 EUs discrete graphics as well.
What's an EU for those who don't know?
EU is the acronym for execution unit. So the more execution units you have, the more horsepower you have for doing things like rendering, ray tracing, AI acceleration, etc. So
are all EUs created equal? For example, you said there are 96 EUs on the IGP, integrated graphics on the processor.
Yeah.
Somewhere, where is it? I think it's up, down, up. I'm not good at pointing at myself, but yeah, it's on the top or the bottom. And how does that compare to the IGP here, compared to an EU on the discrete graphics?
A lot of the technology carries over, but we always are adding new, right? So the discrete graphics in this Alchemist series, A series of our discrete graphics ARC has some new IP that's even newer than what's in the 12th gen integrated graphics. So for instance, it is the first graphics part in the world anywhere that supports AV1 encoding. So even our integrated graphics doesn't have, we have great media engines on our integrated graphics, and they do a great job of encoding, especially doing HEVC to AVC, all the
hardware encode, to be clear.
Hardware encoding, yes. We have some of the world's best media engines for hardware encoding of video, but the Alchemist graphics is the first one that does AV1 hardware encoding.
Okay. And there's some benefit to having both an Intel processor and Intel graphics together. What is the interaction to each other? How is it additive to the system overall, instead of just like switching between integrated and discrete graphics through a MUX or a pass-through?
So another piece of technology that's new in our discrete graphics is what we call XMX, which is an array-based AI engine. Our integrated graphics supports DP4A. And so if you have an AI application, which we'll show you one of these later, to do video enhancement, the application can take advantage of large array scale mathematics to do AI, but it can also leverage DP4A across both of them at the same time, and it can use all of that concurrently at the same time. So that's pretty exciting.
Okay, so AI applications, what else can these two I plus I scenarios work together?
Another thing we do is called, so I'm going through some of the deep link, what we call deep link features. Deep link is linking, when the two pieces of silicon work together, linked. The AI thing we call hyper compute. Okay. The other thing is, I mentioned we have great media engines on integrated graphics, and we have great media engines also on the discrete graphics. So in the case of AV1, it's only discrete because that's the first silicon that does it. But for all your other encoding workloads, we actually have a thing called hyper encode. We can actually, on a single timeline of video, we can actually send groups, what's called GOPs, groups of pictures, to the integrated graphics or the discrete graphics, and then it gets stitched back together at the end. So they're both encoding at the same time.
So hypercompute, hyperencode. I feel that there's a theme here with hyper-threading. It seems like hyper just means like adding or doing more than one thing at a time.
Yep.
Okay, very cool. Is this a feature that's pretty unique to Intel systems that have Intel processors and Intel graphics?
Yep, absolutely.
Okay. I know this is going to be much more popular coming out with more ARC graphics, but I do remember there was similar kind of I plus I benefits with the previous generation, codenamed DG1. What's new between DG1 and what we're seeing with Alchemist? So
DG1 was really just a cut outside of the die of our IP that was already in the 11th gen processors of integrated graphics. So it was just taking our integrated graphics package and moving it to its own die, which was just to us, it was just an enabling effort. It wasn't about moving the IP forward, it was just an enabling effort of how can we make two engines run at the same time. So now that we've moved to DG2, we have totally new IP. So the whole graphics core is really new. The only thing that's consistent is just being able to do that bridge across multiple compute engines.
That's pretty cool, because I know that the IGP for 12th gen is more closely related to the same as from 11th gen, but then you're able to almost, not say bridge, but you're able to make these two intergeneration work together.
Yep.
Okay, very cool. Well, I want to see it. I want to see it in action. Would you mind running me through some demos?
Yeah, I was going to have Ashley, who's our content creation expert and who's been doing these demos way more hands-on than I have, run you through the content creation demos first.
Great.
That's all right.
Yeah, no, that is absolutely great. Ashley, thanks for joining. Just had a conversation with Brett, very enlightening, and I'm excited to see more, so he says that you can show me more. But first, tell me who you are and what do you do at Intel?
I'm Ashley Gregory. I'm a technical marketing engineer within Brett's team, and I focus mostly on the content creation side. So I help create the workloads, I run the workloads, work with the demos and whatnot. And today I'm going to show you a really awesome demo on our platform here. So I have a video, right, of, I like to go bird watching, right? And when you do a software zoom on your cell phone, it's not great quality. It's not amazing whatsoever. It's got pixelation. It's a small size for it when
software
you
zoom, right? It's just,
yes.
you just get a blurry thing just gets bigger.
Exactly, and it's not amazing. So we're going to use Topaz Video Enhance AI today on our ARC platform using our hypercompute. We are going to go ahead and grab that woodpecker video that's not amazing, that no matter what I do, doesn't look amazing whatsoever. And the key thing is I want to be able to use both of the GPUs in the processor. And here, that's what I'm doing. So I'm going to go ahead and start the process. It's going to go ahead and prepare the AI model.
What's the resolution of the original video?
The resolution of the original video is 720p. We are bumping it up to 4K.
From 720p?
Yes.
To 4K?
Yes.
Okay. All right. I have to see this. It is like, I've seen upscalers take 720p video to, I mean, on a big TV to upscale to 1080 or something like that.
Yeah.
But it introduces a lot of noise. So I'm really excited to see how 720p becomes 4K. So we've talked a lot about both pieces of silicon working together. How do I know they're both active? Like, what, is there a sign? Is there a, can I see it in Task Manager?
So when it comes to hypercompute, absolutely, you can see it in Task Manager, but the key thing is that when you click on your ARC GPU, you actually need to drop down the graph and actually show compute, because it's actually using the compute cores on the GPU itself. So that's how you can tell that hypercompute is working on the system. It's just not running on integrated. It actually is running on your discrete Alchemist GPU on your system.
Okay, so again, 720p to 4K. It sounds too good to be true. Can I see it? Can I see a side by side so I can see my before and after?
Absolutely. I will bring those up and show you right now. So what we've just done in this whole workload is we have taken a 720p software zoomed in cell phone camera of a woodpecker. We've enhanced it with Topaz Video Enhance AI using our hypercompute functionality within our ARC GPU, brought it up to 4K, taken that 4K woodpecker video, thrown it into a DaVinci Resolve Studio 17 project that I was already working on that's in 4K, thrown it in there, have done both an export to an AV1 hardware encode, then also shown our hyper encode functionality of being able to use both our integrated and discrete GPU functionality together in order to bring a H.265 video at 4K out in fast time.
Wow, so that's a true workflow for a content creator. Really actually proves this Intel Evo platform with 12th Gen H series and Intel Arc graphics. Pretty impressive. I think this is a really nice first demonstration of what Intel graphics and Intel processors can do together. So Ashley, thanks for showing me. Really appreciate it.
No problem, anytime.
Thank you. And that was Talking Tech for today. I'm really glad I came here to check out the new laptop. This is a reference design Intel Evo 12th Gen H series with Intel Arc graphics Alchemist 370. Had a chance to check out all the content creation demos, ran through a workload with Ashley, got the download with Brett. So I'm super excited. This is just the first of many to come. But this one, I'm trying to take this for myself. They actually made me bring it back. But thanks for joining Talking Tech, and stay tuned for a lot more on the Intel Technology channel on YouTube.